Hello, I'm Dr. Roberta Campbell, and I want to explain some theory about the way that the world's population grows by Reverend Thomas Malthus, who was very concerned that the world's population was growing so fast that we would be no longer able to feed ourselves at some point. And one of the things he made a point about was the fact that populations grow exponentially, whereas food production grows linearly. So I will illustrate that for you. Now, bear in mind that humans are a very successful species, and we tend to grow a little bit naturally because we're also very fertile. But the earliest humans were only able to support a very small population, and life was fairly short. So these kinds of things made a big difference. So we had about 300 million people about 2,000 years ago, about the time of Christ. Now, when we started to industrialize, we didn't just industrialize in terms of building factories to produce. We also mechanized agriculture. And we started to see a quality of life that was really quite better in a lot of ways, and the increased food supply helped to increase population because people lived longer, people didn't die in childbirth, but we still had a lot of children. So right at the onset of the Industrial Revolution, we began to grow our population, and this is what Reverend Malthus first began to notice. We reached our first billion people around 1800, which is 300 years ago. In 1930, a mere 130 years later, we reached our second billion. And now, here it is, 2012, and we have reached 7 billion people. So we are doing pretty good in terms of increasing our population. But what Malthus noticed, by the way, Malthus was an economist. He was a pioneer in demography. He was also a minister and a rather prolific writer. And he noticed that populations tend to grow exponentially, or as we said, populations grow. Another way to say this is that populations grow in multiples or geometrically. But he also noticed that food supplies grow linearly or arithmetically in a straight line. And he also noticed that this was very closely connected to our development as a society, our industrial development in particular. But what he thought is that population growth would exceed the availability of the supply of food, which would result in starvation and war, also disease. This would be a kind of positive check, positive not meaning good, but meaning real check on population, unless we practice some preventive kinds of checks. But what I want to concentrate on here is this explanation of exponential growth. And again, as I said before, he found a relationship between population growth and economic development. And I've kind of illustrated population growth here by my family reunion. We're a pretty big group and growing all the time. There's little ones, big ones, older ones. You know, and I'm hoping we continue to grow, but we need to be able to feed ourselves, because that's one of our big deals with our family reunions, is to get together and have plenty of food. So what we mean by exponential growth, we are adding a larger amount each time, in other words, multiples. And I've illustrated it here by imagining 1,000 bushels of wheat in a particular community. Now, not being a farmer, I don't really know how much wheat we need to make our bread and our donuts and our cakes to feed us in a year, but I'm just imagining this particular community produces 1,000 bushels of wheat in a single year, and that there are 1,000 people who live in this community, and the population is growing. And I'm saying linear means 1, 2, 3, 4, 5, and exponential is illustrated by 1, 2, 4, 8, 16. Doubling times, we call this. So in year 1, we increase our food production by 100 bushels of wheat. So that year we produced 1,100 bushels of wheat. We increased our population by 10%. We're still even. We have 1,100 people. Year 2, we added the same amount of food production, and we produced in that year 1,200 bushels of wheat. But we added 10% to a larger amount of people in that year, and this year we now have 1,210 people. Not a big deal. We only have 10 more people than the amount of bushels of wheat we produced. Let's look at the year. We have produced in that year 1,300 bushels of wheat, we are imagining, but we have 31 more people in the population in that community because we added 10% to 1,210 to get 1,331 people. Okay, so now we're going to the year 4, and we added another 100 bushels of wheat, equaling 400 bushels of wheat produced in that year. We added 10% to the population, so we now have 1,464 people. Still not too bad, but let's skip ahead 4 more years. In year 8, we produced 1,800 bushels of wheat, but in that year our population grew to 2,143 people. Let's skip ahead another 8 years. Now we're at year 16, and here we begin to really notice a problem. We have produced 2,600 bushels of wheat in that year, in that single year. However, at this population growing 10% a year, by year 16 we've got 4,597 people. We've added almost 2,000 since year 8. So we're starting to see a possible problem in our ability to feed people who live in this community with the amount of wheat that we are producing. So as you can get the idea here, then, we have a problem in terms of feeding the world's population. Now, there are other issues involved. We also need to worry about our resources in general. But you get the idea here that Malthus and others have noticed that we are quickly going to overpopulate to the point where and we have in some places already reached the ability to take care of the number of people on the world. So let's all think very hard about this and be willing to find solutions. Thanks.